Yeah, good. So synthetic division. So I'll give the steps and then we'll do an example. But it should be noted from the word go that this only works when you are doing division by a linear factor of the form x minus k. So note, this method only works when p of x is divided by a linear factor so a linear polynomial of the form so that means that we are dealing with the division of a polynomial p of x divided by x minus k. If the polynomial, if the division is not by a linear polynomial of the form x minus k, this method doesn't work. So step one, write the coefficient of the given polynomial. So write the coefficients of the given polynomial p of x, including negative signs, in order of descending powers. That means that if you have the highest power of x in that given polynomial, say is 4, then you write the term starting with x power 4, followed by x power 3, followed by x power 2, up to the term without x. In case So in case one of the terms involving x is missing, then you take its position by coefficient of 0. For instance, when we're dividing x power 3 minus 8, you see that that's a third degree polynomial, but there's no term with x power 2, there's no term with x power 1. So those steps or those positions of x power 2, x power 1, you replace the coefficients by zeros. So that's what that means. Step 2, place the number k in a box at the left end of the row of coefficients listed in step 1. So place the number k in a box at the left end of the row of the coefficients listed in step 1. We'll do an example to illustrate how we fix that box. 3. Bring down the first coefficient of row 1 multiply by k add the product to the second coefficient in row 1 and bring down the sum. Bring down the first coefficient of row 1, multiply that coefficient by k, then add the product to the second coefficient in row 1, and then bring down the sum to the same line you had written the first coefficient in row 1. Then second last step, repeat multiplication and addition until all the coefficients of row 1 are being used. So that means that repeat step 3 up to the last coefficient in row 1. And then lastly, the numbers in the third row except for the last one are the coefficients of the quotient. So the last number in the third row is the remainder. So that is the whole process on synthetic division. One key thing is that synthetic division is only applicable when we are dividing a polynomial p of x by a linear polynomial x minus k. So you have to know what is k, then write the coefficients of the polynomial in decreasing powers of x, and then do this multiplication and addition to get the quotient and the remainder. So let me explain the process with examples. So let's start with an appetizer. So let's repeat this problem that we have just solved in the previous session. What is the quotient in x cubed minus 8 over x minus 2? So the first question you ask yourself, does this problem qualify to be solved by synthetic division? Yes or no? Reason?
It is.
Yeah. So the divisor is in the form x minus k. Okay. Yeah. So then that applies. So what will the first step is to write the coefficients of the given polynomial p of x, including the negative signs if there are any, in order of descending powers of x. Then include 0 for coefficients of each missing power of x. Now, what is the degree of the dividend? Degree of the dividend? Yes? I'm asking what the degree of the polynomial x cubed minus 8? 3, okay? Yeah, highest power of x is 3. So when you have a polynomial of degree 3, you expect it to be of this form. There's a a3 x power 3, a2 x power 2, a1 x, and then a0. So this is a general structure of a polynomial of degree 3. So what is a3 in our case? I'm just asking, what is the coefficient of x power 3?
X raised power 3 minus 3.
Coefficient of x power 3 in this numerator. Come on. What's the number before x power 3?
The number before power 3 should be power 2.
Okay, I want you to use your eyes. What is the coefficient of x power 3? What is the number before x power 3 in this numerator?
X.
Or you are not happy with that question? If I give you 6x squared minus 4x plus 3, what is the coefficient of x squared?
X.
Or what is coefficient of x?
One.
And the same problem.
In the 6 raised power x or the x cubed.
I'm referring to this, what I've written here. What is the coefficient of x? Negative 4. So now, when I go back to the question I'm asking, what is the coefficient of x power 3? One. So this can be written as just 1 x power 3. Now, if you have a polynomial of degree 3, then this should be the structure. So the next term should be x power 2. But what will be the a2 if this is the polynomial we have? What is the value of a2, coefficient of x squared?
No, that coefficient will, when we solve it, it should be back to x raised to power 3.
Yes, 1 times x power 3 is x power 3.
Okay, so it will be
So remember, we were told that if there is no term, in the descending powers of x, we use the coefficient 0. We replace 0 in that position. So in our case, we have 0x power 2. We have 0x, and then there's minus 8. This is what we have. Okay? Yeah.
Okay. Madam, I have a question before we continue.
Yes.
In what scenario are we, maybe, will we have a coefficient that is not 0? Maybe let's assume you're having 5x cubed. The next one will be 4x squared, 3x, like that.
No.
In that order.
So here, remember, you have to write, the first thing, you have to know the dividend is a polynomial of which degree. And when you say degree 3, then there's a term in degree 3, followed by a term in degree 2, followed by a term in degree 1, and then the constant. So those terms which are not in the question, you replace their coefficients by 0, because they will not have any effect on the question. You should be able to see that when you simplify this, it's still back to the original expression. Because when you say 0x squared and 0x doesn't change the value of this polynomial. But we need to place them there so that it gives the general structure of a polynomial of degree 3 in x.
Okay, and that's good.
Fine. So then coefficients are 1 followed by 0 followed by 0, finally
and
negative 8. Correct. So that is step 1. Then step 2, place the number k in a box at the left end of the row of the coefficients listed in step 1. Place a number k in a box at the left end of the row of the coefficients listed in step 1. So in our case, what is the value of k? What is k? Remember, the problem you are solving in this process is p of x over k minus x minus k. So what is k? Negative 2. Don't forget where we are moving from. We are describing how to carry out this division. P of x over x minus k. And our question is x cubed minus 8 over x minus 2. So if I relate these two, what is the value of k? K is 2, not negative 2. Because remember, it's like kx minus k is how the formula should be, the structure of the division. So if you have x minus 2, then the place of k is taken by 2, not negative 2. You will say k equals negative 2 if the sign was plus. Okay? Yeah. So then k is 2. So this is the row of coefficients. Then you can draw. So that's how we draw the box. And then you put that value of k in that space. for k is 2. And then skip a line and draw a line. Once we have found k, we have listed the coefficients in the polynomial p of x, skip a line, or maybe say skip 2 lines, and then draw another line. And then we go to step 3. Yes? George? We are describing a process. We are now at step 3. Step 3 says bring down the first coefficient of row 1. So what is the first coefficient of row 1? This is the first row. So what is the first coefficient? First coefficient of row 1? 1. So that's what you bring down. So bring down, then write this one here. Okay? Then after bringing it down, multiply it by k. Okay? So what is the value of k in our case? Please don't watch. Ensure that you write what you're writing. So if you watch, you'll never get what's happening here. I assume that you are writing this scheme here. If you watch, you will not understand what's happening here. It may cheat you that things are easy when it may not be the case. So once we have brought down the first coefficient in row 1, multiply it by k. So what the question is, what is our value of k in this question? So when you multiply 1 by 2, we get 2. So multiply it by k and add the product to the second coefficient in row 1. So 2 times 1 is 2, and then that 2, I write it in this place. So bring down the first coefficient, take k, multiply by that number, and then the answer you get, you write in row 2. So this position here. Once you have done, then bring down the sum. So you add things which are on the same column. So 2 plus 0, or 0 plus 2? 2. So you write that 2 in this position. Then we repeat the same process. So we are going to have k times this number 2. What do you get? 4. That 4 you write in this position. So the next step, I'm adding what and what?
0 and 4.
0 and 4 to get 4. Correct. Next step.
You take 4 times 2.
And then the answer is
8.
8. And when you add,
Then
0. Correct. And remember, we were told that the last number in row 3 is the remainder, and the first values in that row forms the coefficients of the quotient. So this will make this common sense that if I have the highest power in the numerator is x power 3, and the highest power in denominator is x. So you expect the quotient to have which power at the highest? 2. So when you are dividing a polynomial of degree 3 by a polynomial of degree 1, then the quotient will be a polynomial of degree 2. Similarly, if you are dividing polynomial of degree 4 by a polynomial of degree 1, you expect quotients to have a maximum of which degree? 3. So you reduce by 1 if the denominator is always of degree 1. So that means that the quotient is a polynomial of degree 2 because the numerator was a polynomial of degree 3. In the denominator of the divisor is a polynomial of degree 1. So x power 3 over x power 1, x power 2. So, and a polynomial of degree 2 takes this form, a2x squared plus a1x plus a0. Okay? This is the structure of a polynomial of degree 2 in x. So which means a0 in this question is, a2 is given by, from the third row, 1, and then a1, 2, and then a0, 4. Remember, the last number is the remainder. So remainder is 0. Okay? So therefore now we simply say x power 3 minus 8 over x minus 2 is the same as a2 is 1 times x squared, so we have x squared. A1 is 2, so plus 2x. A0 is 4 plus 4. Remainder is 0. So this simply x defines or tells us that x minus 2 is a factor of x cubed minus 4, x cubed minus 8. Which is the same number that we had initially. I know maybe that didn't make sense. So let's see the second one. So divide 4x power 3 plus 16x plus 11 minus 13x squared by x minus 2. I want you to guide me on what I'm supposed to do. By? So what are the coefficients? Yes, the first thing is to rearrange, okay? Arrangement is the first thing, so that you write the polynomial in such a way that you start with the term with the highest power of x up to the term without or with low power of x. So the first one in this case will be 4x cubed
minus 13x squared
minus 13x squared
plus 16x
plus 16x
plus 11.
plus 11. And then you divide this one by x minus 2. So what is the degree of the polynomial in the numerator? 3. So what are the coefficients? So k in this case is
2.
2. And then, so the coefficients we have?
We have x cubed.
X cubed is not a coefficient.
Okay, we have 4.
4?
Then we have
Maybe 13. Negative 13. 16. Please don't be lazy. You write all the coefficients. So remember, these are polynomial of degree 3. So a3x power 3, a2x power 2, a1x plus a0. So ai's are the coefficients. So these numbers before x's and this up to this constant value. You write in that order, starting with the term with the highest power factor. So then we write this box, then this is 2. So 4, leave some space, minus 13. Then we have 16, and then we have 11. So what should I do next? We'll skip 2 lines, say for example, and then I do a line, okay? And then I drop the first coefficient 4. I write it here. Then by to get, and then I write in the second row, okay? Yeah, and then minus 13%. What do you get? -5. For the next step, by to get -10. Yeah. Yes. 16. Negative. Is it negative? Positive. Is George in class? The next step.
We take 2 multiplied by 6.
Get 12. To get are you subtracting? What is this? What happens to k times the number you put in the third row? Once you get this is 12, what are we doing? Are we subtracting or we are adding? Okay, just ask yourself, how did you get 6 from 16 and minus 10? What and what?
No, that's it's a 16 minus.
We are not subtracting, we are adding. It is k times the number in the third row. The answer you get, you put it on the second row and then add the number above that value to the new number.
Yes, 23.
Okay.
Yes.
So which means 4x cubed minus 13x squared plus 16x plus 11. If I divide by x minus 2, what is the quotient? First term of the quotient? Yes, because we saw this power 3, this power 2, so we expect the highest power in the quotient to be x power 2. So 4x power 2. And then and then plus the remainder over the divisor, which is 23 over x minus. Yeah, remember we said dividend over divisor is quotient plus remainder over divisor. Okay. Yeah. Number 3. Divide x power 3 minus 3x squared plus 4x minus 5 by x plus 3. So remember, the process is to have a polynomial p of x over x minus k. So we have x power 3 minus 3x squared plus 4x minus 5. How can we write x plus 3 as x minus a number? Minus 3, okay? Yeah, so which means k is negative 3. And the polynomial is actually in the correct form such that we have all the coefficients are taken care of. Huh? Yeah. So we have minus 3, and then first coefficient is 1, followed by minus 3, followed by
4,
followed by
negative 5.
negative 5, correct. And then what should be the next step?
You skip 2 lines and drop
A line,
1.
and then drop 1, okay?
Yeah.
Yeah. And what happens next?
You multiply negative 3
By
1
to get
1, negative 3.
negative 3. Okay?
You write, yes. Then you add
So after adding minus 3 plus minus 3,
minus 6.
minus 6. Next step,
You multiply negative 3 by negative 6.
get
18.
18.
You add 4, you get 22.
22. Next,
You multiply negative 3 by 22
to get
to get 66.
positive,
No, negative.
negative 66. And then
You add 5, you get 71.
positive.
Negative.
Okay. So that means that x cubed minus 3x squared plus 4x minus 5 over x plus 3 is first term.
It will be x squared.
X squared
Minus 6x
minus 6x
plus 22.
plus 22.
And then you add negative 71 over x minus x plus 3.
X plus. Or you can just write one negative sign in terms of x plus 3. Okay? Can you be trusted with this? X power 6 minus 4 divided by x plus 2.
Okay, let me try.
George, are you in class? George? Okay, what's the trick here?
The trick here is to write it to check on the coefficient.
So how do we write the polynomial x plus 6 minus 4 over x plus 2?
It will be writing plus the coefficient.
So I want you to give me the first step.
I'll write x raised to power 6
x power 6
plus a 0. Let me see how to fit.
plus a 0.
0 x. Just a minute. I think it's x raised to power 0.
No.
X
Remember,
power,
don't confuse yourself. If you have what is the degree of the polynomial in the numerator?
it's 6.
Degree 6. So degree 6 will take this form: a power 6, a6 x power 6, a5 x power 5, a4 x power 4, a3 x power 3, a2 x power 2, a1 x up to a naught at the final term.
Yeah, so it will be 5 x raised to it will be
remember step 1 we said you write the coefficients of the given polynomial, including negative signs if there are any, and in order of descending powers of x. Then include a 0 coefficient for each missing power of x. So remember, when we have x power 6 as the highest x in the polynomial, then it means that that's a polynomial of degree 6. So we need to have a term in x power 5, x power 4 up to 0, x up to a power a sub 0. So those
0 x raised to 5.
And then plus
0 x raised to 4.
And then plus
0 x raised to 3.
Plus
0 x raised to 2.
Plus
0 x.
Then plus.
Then it's an a0.
What is a0 in this case?
X raised to 0.
You see, a0 is the constant without the x, so you already have minus 4. So you don't minus 4, okay?
Yes.
This is x minus 2. So what is the value of k?
Which is minus 2.
Minus 2.
Yes.
So we'll have now, you draw the box, put minus 2 here. So we have 1, 0, 0, 1, 2, 3, 4, 5. Then negative 4. And then skip 2 lines. Draw this line. And then you drop.
You drop 2. You drop 1, I mean.
1, yes.
Then you multiply 1 by negative 2, which is a negative 2.
And then
you add, you get negative 2.
And then
you multiply negative 2 by negative 2, you get a positive 4. You add, you get 4. You multiply negative 2 by 4, you get negative 8.
Then
you add, you get negative 8.
And then
you multiply negative 8 by negative 2, you get negative. You get 16, a positive.
16 positive.
You add, you get 16.
Then
you multiply 16 by positive 16 by negative 12, you get 32. which is a negative.
Yes.
You add, you get negative 32. Then you multiply 32 by 2, you get 64, which is a positive.
Then you keep that.
No, no. You add, you get 60.
60.
Yeah.
So that would mean x power 6 minus 4 divided by x plus 2 is equals to?
It's equal to x raised to power 5
X power 5
minus 2x raised to power 4 minus plus 4x raised to power 3 minus 8x raised to power 2 plus 16x minus 32 plus 60 over x plus 2.
I hope now you can now solve other problems by the same method.
Yes.
Yeah. So break and then you come to finish.
Okay.